There was recently a stir up on social media about a visualization that appeared in the Georgia Department of Public Health's daily status report for COVID. And the chart in question was showing data about the top 5 counties and how COVID cases, day to day, have changed. I believe it's supposed to be new cases, although it's not totally labeled here. And the problem with the original chart was can actually be found in a post that Alberto Cairo recently wrote about the chart with a redesign that he did. So here's a screenshot of the original chart that he's embedded in the post. And what you can see is the problem is that if you look on the axis here, the data is not actually sorted by date. It's actually sorted, it seems like, almost by high to low of the entire group. So that causes some problems because in this case, I believe the purpose of the chart is to understand sort of the trend. It's very difficult to understand whether cases are sort of trending upwards or downwards if the data is not sorted in that way. So you could see that pattern. There's also some issues with like the bars themselves being sorted high to low within each subgroup. So like the colors kind of move around rapidly, making it harder to compare. Now, since they were kind of critiqued for that, the chart's been updated. So now the groups at least follow a same order within them, and they're also on the kind of outside of the axis, the dates are in the right order. So you can at least learn a little bit something more effectively with this visualization. Now this is one way to approach fixing this chart. In Alberto's post, he does a redesign where he actually does it slightly differently. He actually breaks out the groups by county. So you get sort of individual county trends that can be compared this way, which is pretty nice because you can see what's going on with each county individually, but you can also sort of compare them to each other very easily. So what I want to do today is load some of this data into NAR and replicate some of these analyses ourselves, as well as like maybe tweak that a bit further, see what else we could do with the data and what else we could learn. Now the data for this report, I couldn't find the exact data they're using. I don't believe it's public. It's coming from the Georgia Department of Public Health, and the data they link to here is only the latest data. It's not the daily data. But I used the CDC's website to look at the county data, and they link to usafacts.org where they have data collection at a daily level for counties across the US with total cases. So I pulled that file. So that information is not 100% sync up with the Georgia report, but it's very close, just off by a few digits here and there. So I'm going to use that file, which I've downloaded, and I'm going to go ahead and start a new NAR project where we can load in that data. So I'm just going to add a data set here so we can start loading data for exploration. I'm going to call it this just Georgia COVID. And I can drag and drop CSV files that I have that I'm ready to analyze right into the tool. So I have this COVID cases county daily. I'm just going to drop this in here. It's going to upload the file for me so then I can load it into the tool. And when it's done uploading, we'll be able to look at what the fields are. If we want to change something about the data, we could here, like if we wanted to do some additional sort of manipulation. In our case, we'll just look at what we have. We have sort of a date, a state, county name, state code, county code, confirmed cases, and then a column I added called new confirmed cases that just sort of calculates the changes from day to day for the confirmed cases in a county. So we'll call this COVID cases. And I'll just load this data into the tool. So now we have our 330,000 records. This is like a bunch of dates and states and counties and what the confirmed cases were for the day total and what the new confirmed cases were for that day. So let's go ahead and go to the Explorer view and actually try to recreate some of these charts. I'm going to make a little note here where I can keep track of what we're doing. Call this chart reproduction, I guess. And the first thing I want to do is just get down to the data that they were looking at. So if I look at the original image here, they said they wanted the 5 biggest counties, which are Cobb, DeKalb, Fulton, Gwinnett, and Hall. And it looks like the dates are April 28th to May 9th. So let's just go ahead and filter down to that data. I'll go to the state. We're talking about Georgia. And then let's look at the counties, and we'll get Fulton, Hall, Cobb. What else was it? Let's see. We had DeKalb and Gwinnett. So we'll get DeKalb County and Gwinnett County. So we got those 5 counties, and then here are 119 dates. We really want to look at just the dates that are greater than April 28th, 2020, and less than or equal to, I believe it was the 9th, something like that. So 12 days, maybe that's not exactly right. Let's see. This is 28th to May 9th. Okay, so we'll load those days, and there may be some information missing in there for certain data points. Okay, so we're looking at dates from May 9th back to April 28th, and now we want to make the chart. So the first thing we'll do is we'll start with like a simple bar chart, and we'll add as a dimension the date field. So there's our date. We're just seeing sort of even distribution right now, but what we really want to look at is like the number of cases, right? So we'll just do a summation of the new confirmed cases. And we'll get a nice little histogram like this where we can see sort of the trend of new confirmed cases from day to day. Let's just expand it so we can look at it a bit more closely. This is pretty cool. It's a good starting point. We can kind of see something going on here. I'm just going to add this to my note as a snapshot. We'll call this our kind of baseline new confirmed cases for top 5 GA counties. And I can use this to get back to the analysis, which we'll see later. Okay, cool. But in their chart, what they were doing is actually trying to break this out by county. And the way they did that was just with like kind of a sub grouping. So we'll do that here. We'll just come into the chart and add county name here as a dimension. And here we go. We got a chart that looks closer to like their chart. Ours is already sorted the right way, so we don't have to change that. And the counties are also sort of already sorted the way you'd expect. We can hover here, so if we do want to like analyze the counties individually, we can at least do that here and kind of in sort of an overlaid brushed fashion to see what's going on there. But we can also just kind of interact here and see the trend. So that's kind of an interesting way to do it. This is like close to what their new version of the chart looks like. So let's just snapshot this and call this sort of COVID report. We'll call this their version of it, right? Now, Alberto's version was a bit different. Alberto's version, he takes the chart and breaks it out by individual counties and has the dates kind of on the inside. So that's easy here. We'll just flip these. So we'll take off the county name here and put it up here. And then we'll change this to the date field. And now we've got this kind of visualization. Now we don't have the colors that Alberto has, like kind of giving each county a color. That would be some more work. But in general, we can kind of see the same thing about what's going on. Like here's the trend for Cobb, here's the trend for DeKalb, etc. Now the colors are kind of obnoxious, I would say, to have this many colors, and it's not really that helpful for this kind of data. Alberto's is much nicer, but we may not even need the colors. So actually what we can do is we can go back to let's call this Alberto's version, even though it's not his version because we're not coloring it like him, so I don't want to ruin what he had. Call it the Alberto-esque version. So let's go back here and say, okay, well, we don't need to color these. And so what we could do instead is actually just do a normal trellis that keeps the chart color basically the same. And what I mean by that is like, let's go back to our baseline just by clicking here. Here's our chart based on kind of the dates. I could say, okay, let's, instead of grouping this, let's actually break out the columns and say, okay, you know what? We wanted to do the columns by county name. And now I've got columns for each county name, and I can shrink these up so we can fit more data into the view. I'll just shrink up the minimum column size and the minimum bar size up here. And here we go. Now we've got all 5 plots. We have Cobb, DeKalb, Fulton, Gwinnett, and Hall County put out here. So this was looking a little bit closer to what Alberto had without sort of the separate colors for each county. This is sorted alphabetically, but we could sort it, based on the value as well. So we could sort this this column here by the descending value, and that'll put Hall in the front. So we know Hall is the one with the most new cases during this time period. Then we could see Gwinnett, we can see Fulton, Cobb County, etc. So let's go ahead and just like stash this one as well. So we'll call this sort of county columns. Now, this is interesting, and like when you have them in columns like this, which is kind of cool about having them in columns, just like in the functional art blog post, is that you can easily sort of compare values to each other at different times. However, it can be a little bit difficult to like understand like how dates compare to each other. I mean, in R we have some brushing capabilities to help that, but sometimes you might want to see like the trends actually on top of each other, right? So instead of looking at it, the charts sort of next to each other this way, where you can compare the Y values, you may want to more accurately compare the position of the X values. And so what I can do to do that is really, let's just take it out of column mode and let's switch it into row mode here. So let's just add county name as the row instead. And now I've got multiple charts per row, and I'll shrink up the minimum row size so we can see a bit more what's going on there. And now I could compare these things together across the various rows. If I hover a bar, at least I get like sort of a line showing me the reference in other plots, so I can see, how the other data points relate to that hovering, even though I don't have them side by side in that way. So it's another interesting perspective on the data. We'll just call this sort of the row county breakdown. And from here I could do even more analysis. I could say, let's just like look at all the dates for these top five counties. So I'll just remove this date field, and let's go ahead and give this a nice little name here so we can read our chart more effectively. So now I have a nice plot here where I can scroll through all these dates. I can do annotations and highlight, look for dates that like had a certain amount of new cases. I could sort these rows value descending as well. So let's go ahead and do that. So we get, the top counties at the top. So this is interesting. This is sort of like all the days, and we'll go ahead and we'll keep snapshotting here. Call this all counties top 5 counties row, all dates. And from here I could even like clear the county selection and look at the new cases for all the counties. So like maybe I'll clear this, and now we've got a bunch of counties here. We're going to make these plots a little bit bigger because they're hard to read, but we are also going to probably quickly notice something weird in the data. We have negative new confirmed cases. And if we look through the chart, we can kind of find out where that's happening. It's happening in this statewide unallocated county name. So this is sort of a county name that was put in the data that doesn't actually reference a county. So it's some sort of dirty category in our data that for our analysis, maybe we just want to ignore these values, and they clearly like don't match the formula that I used to calculate what the new cases were, because they're not meant to be sort of a cumulative value in that way. This doesn't actually represent a region. So what I can do to quickly get rid of those is just like, it was called statewide unallocated. So I'll just like make a selection or a search for just anything that has the word county in it. And that'll get rid of that one value. So we've got that dirty data out of there. And now we have a nice plot. We can see kind of what's going on here across all these different counties, and we can hover and interact and see, all time Fulton's actually at the top above Hall, for example. In fact, Hall, when you go outside of that time period, is much farther down the list of the top 5 counties. It's right at the bottom of the top 5 counties. We can go from here. So we could do more things here. We could add more data. Like maybe you don't want to just look at new confirmed cases. Maybe you want to look at like all cases. And so we could change this to be just to see like kind of a trend of how cases have accumulated over time. So we can change this to look at sort of confirmed cases and just see like what all the cases look like over time. And now we get this nice chart where we've got sort of the accumulations here. But maybe we want to break that down by population as well. Like maybe we want to know the cases per 100,000 residents or something like that. So if you go to like the census's website, you can find that information, like kind of the population estimates for all the counties in the US. So I have that file as well, and I can easily just sort of add it in here. Got county population for 2019. I did a little bit of data prep to just get the keys lined up where county FIPS would match this county FIPS. So we'll call this population data. If we generate a preview just to see what it looks like, it's got the county code and then the population estimate for 2019. So I can apply that change there and then have that linkage. And that means that, when I'm looking at county names here in confirmed cases, I could also like interact with or associate that with population estimates to do formulas like looking at population density, sort of like cases per 100K. So if I go back to my cases here, instead of doing just a sum of the confirmed cases in my formula, I could change that to maybe a sum of confirmed cases divided by the sum of the pop estimate 2019. I think I'm doing that right. Yes. And then we'll multiply that by 100K. We'll just call that C per 100K. And now I've got sort of cases per 100K, and you can see the sorting changes much differently. So Randolph County, which is a much smaller county in Georgia, their cases per 100K, of course, looks much more significant. I think they have something like 169 cases, but their population is very small compared to like Fulton County, which has over 1 million people. But it's another way to look at the data and break it out and kind of explore that way. And we could certainly do new confirmed cases as well. Now I could make these all snapshots. As you've seen here, I have all these snapshots. I could go back into what we were looking at before, like the top 5 counties in all the rows, or the sort of Alberto version or the COVID version, or how I had my row county breakdown just for those select dates. But I didn't save some of the later stuff I'm doing, which is okay because I actually have history of all my analysis down here, so I can come here and actually recover stuff I was looking at before, like when we were looking at let's see, maybe something these 159 counties in Georgia. When we filtered out that statewide unallocated value, we can quickly get back to that, even though I didn't snapshot it, and work from there. So I hope this gives you a sense of all the possibilities with the simple data set, like the COVID kind of county numbers, and the various ways you could sort of analyze it, both in a single graph, but also with small multiples and manipulating the metrics and the time frames and things like that.